All right, so we are going to do our second day here of notes on solving equations where we have radicals involved. Okay, so um, previously we had it where we just had something raised to a power, and then to get rid of those powers, we took radicals. Now we are going to do basically the opposite of that. All right, so now we have radicals or square roots, cube roots, fourth roots, fifth roots, whatever in an equation, and we need to be able to solve those. Okay, now basically it'd be two types of problems we're going to have. Either we're going to have a radical on just one side of the equation, or we have radicals on both sides. Okay. Now, what we want to do here in order this number 7 is just like before, we want to isolate this square root. Just like if we had 2x minus 3 quantity squared, we want to isolate that first. Well, that's what we do with the square root here. So we're going to add the 5 to both sides. So we would have square root of 2x minus 3 is equal to 5. All right, now, just like if we have x squared equals a number, to get rid of the x squared, we take the square root. To get rid of a square root, we are going to square it. We're going to square both sides. So we're just doing basically the opposite, the inverse of what we were doing before. Okay, so the square root of 2x minus 3 squared is 2x minus 3. 5 squared is 25. And then we solve this, we get 2x equals 28. And then we get x equals 14. Now, a little asterisk here. You must check for extraneous solutions. I can't really spell. Extraneous solutions. Why? Because we raised it to an even power. All right. If anytime you raise, we're solving the problems with radicals to an even power, you have to check for extraneous solutions. Well, in this case, if I have 14, I plug it in. 2 times 14 is 28. 28 minus 3 is 25. The square root of 25 is 5. 5 minus 5 is 0. We're good. It works. All right. So the answer is 14. You'll see an example we do later on where if we get an answer that will not work. All right. So you only worry checking if you're raising both sides to an even power. If it's an odd power, you don't have to worry about it. All right. All right. So now number 8. All right. This is my favorite because we have one on both sides. That's all there is. There's not multiple on either side. It's just one. All right. So, I mean, if we did this, right, if you cube both sides, what happens? They just disappear. So when you have something like this, you just have to set whatever's underneath equal to each other. 3x plus 5 equals x minus 1, which is what? 2x equals negative 6. X equals negative 3 is your solution. All right. We don't need to go back and check because you're taking the odd, you're doing an odd root to each side. So if you see them the same like this, really you're just doing deciding whatever is in the radicals equal to each other. All right. Now, if it was a square root, you might have to go back and check it, but it's not. It's a odd root, so we don't have to worry about that. All right. So now number 9. All right. We have one equation. We have just a square root over here, one radical. All right. So it's already isolated. So it's a square root. So we're going to square both sides. And we get 3x plus 18, the radical is gone, equals x squared. So in order to solve this, now we're going to set this equal to 0. So 0 equals x squared minus 3x minus 18. We factor that to x minus 6 times x plus 3. So we get two possible answers here, 6 and negative 3. Since we did an even power on both sides, we need to go back and plug in and check. So let's plug in 6. 6 times 3 is 18. 18 plus 18 is 36. The square root of 36 is 6, and 6 does equal 6, so we're good. So this one's good. Negative 3. If I plug in negative 3, 3 times negative 3 is negative 9. Negative 9 plus 18 is 9. The square root of 9 is 3. But 3, does 3 equal negative 3 when I plug negative 3 in for that x? Nope. So this is an extraneous solution, all right? So the answer is just x equals 6, all right? If this was an odd root we raised both sides to, we wouldn't have to go back and check. But since we raised both sides to an even power, all right, that's why we were going back to check for extraneous solutions. Okay. All right, now number 10. All right, number 10, a little longer, a little more complicated. All right, we only want to have one radical term on each side. All right, we don't want to have more than one radical term on each side of the equation. All right, so let's move this over there. All right, so that will give us the square root of 5x minus 1 equals 1 plus square root of x plus 2. Or if you write the square root of x plus 2 plus 1, it doesn't make a difference. Okay. So we are going to now square both sides, all right? Because we want to get rid of this square root, all right? So we're going to square and square. So the square root of 5x minus 1 squared is 5x minus 1. Now, 1 plus the square root of x plus 2 is not just 1 plus x plus 2 and the radical disappears. This is a binomial. We are squaring it. So you have to do, like, you FOIL it out. So it's 1 times 1, which is 1, right? But then you would have to do 1 times this and that times that. So it's 1 times x root x plus 2, which is the square root of x plus 2, but then we double it. So it's 2 root x plus 2, right? If you FOILed it out, you would just get that and add it together. Plus the square root of x plus 2 times the square root of x plus 2 is just x plus 2. So what we're able to do is we took the two radicals and now we just have 1, okay? This is different than the second one we did today because you just didn't have the square root of x plus 2. We have this plus 1. This thing here changes everything. All right, so let me just simplify this a little bit. We have 5x minus 1 equals 3 plus 2 root x plus 2 plus x. All right, so now, all right, we only have one radical. So let's isolate this radical, all right? So I'm going to subtract the x over, and I'm going to get 4x. I'm going to subtract the 3, I'm going to get a negative 4. So it's 4x minus 4 equals 2 root x plus 2. And I'm going to divide by 2. Divide those by 2. It's each term divided by 2. So I get 2x minus 2 equals the square root of x plus 2. All right, so now we need to get rid of this radical, square root. So we're going to square both sides. All right, we're going to square both sides. So 2x minus 2 squared, all right, that's going to be 4x squared. 2x times 2 is 4x. We double that, so that's negative 8x. Negative 2 squared is a positive 4 equals x plus 2. Set this equal to 0. 4x squared minus 9x plus 2 equals 0. All right, and go ahead and see if you can then factor that. All right, so this does factor to 4x minus 1 and x minus 2, right? 4 times 1 is 4, 1 times 1 is 2. I get 4x minus 2, which is negative 8x. Negative x gives me negative 9x. All right, so I get 2 possible answers. However, I need to check for extraneous solutions because what did I do? I squared both sides. I raised it to an even power. All right, so I have to go back in and check 1/4 in for all these x's, see if it equals 1. I got to plug in 2 and see if it works. Go ahead and check those out right now. All right, so let's see what happens here when you check them. Let's do the fraction first. All right, 5 times 1/4 is 5/4. All right, 5/4 minus 1 is 1/4. So I have the square root of 1/4, which we'll do in a second. Square root of 1/4 is actually what? 1/2. All right. So then I get 1/4 plus 2, which is 9/4, and the square root of 9/4 is 3/2. So I get 1/2 minus 3/2, which is -1. -1 does not equal 1, so 1/4 does not work. Plug in 2. 5 times 2 is 10. 10 minus 1 is 9. The square root of 9 is 3. So I get a 3. 2 plus 2 is 4. The square root of 4 is 2. I get a 2. 3 minus 2 is 1. This works. So x equals 2. All right. All right. Nice job. All right. So we get 33 out of 32 and 31 out of 32. All right. So just to recap. All right. We raise it to the -5th on both sides. So we get w minus 1 squared equals 4 to the -5th. I rewrote 4 to the -5th as I wrote 4 to the 5th as 2 to the 10th, and it's on the bottom because it was a negative exponent. All right. The reason I did that is because when I end up taking the square root of both sides, the square root of 2 to the 10th is just 2 to the 5th, which was just 32. We added 1, 1 plus 1 over 32. You can actually do that, and you get 33 over 32 and 31 over 32. All right. All right. Last one, 13. All right, let's raise it to the denominator. Since it's negative, we're going to make it negative. So we're going to raise it to the -3rd. So we get 2t minus 3 squared equals -1 to the -3rd. All right, -1, -3rd. So I could make this 1 over -1 cubed. Well, -1 cubed is just -1. So I get 1 over -1, which is -1. So it's 2t minus 3 squared equals -1. All right, what's the issue here? Well, when I take a square root, I get a imaginary. I'm only looking for real number solutions. Done. No solution. Stop doing the problem. You are done. All right, so that concludes this lesson. You're going to be working on that same worksheet for your assignment, and you will I'll tell you what numbers you need to do, but it's going to be from the same worksheet that you had before. Next class, we'll have a review sheet for you. Then next week, we'll have a little assessment on this. All right. If you have any questions, please reach out and let me know. All right. Have a good one, guys. See ya.